the digits of a two-digit number differ by 3. If the digits are interchanged and the resulting number is added to the original number, we get 143. What can be the original number? Now, the information that is given to us is, we have two pieces of information. The first is that it's a two-digit number, so it's a two-digit number. It's a two-digit number. And the digits differ by 3. So if the digits differ by 3, then it is clear there will be the smaller digit in that number. One digit will be the smaller digit and another one will be the larger digit. It's for sure. Okay. This much is sure, that is, one digit will be the smaller one and one digit will be the larger one. If we take the smaller digit as x, and if the difference between the two digits is 3, then clearly the larger digit will be 3 more than this x, that is x plus 3, right? Because if you want to check larger digit minus smaller digit should be equal to 3. So larger is x plus 3 and minus x, if you solve it, you get as 3, right? Okay. Now, some of you will ask that, hey, here you have taken x as a smaller digit, therefore x plus 3 will be the larger digit. What if we take x as a larger digit? In that case, your smaller digit will be 3 less than this, that is x minus 3. And if you want to check it, larger, that is x, minus smaller, that is x minus 3. You get x minus x plus 3 is equal to 3. Okay, so these two things are clear to us. That is, if you take the smaller digit as x, your larger digit will be x plus 3. If you take this larger digit as x, your smaller digit will be x minus 3. Okay, now let's move to the next point. Now here we know that we have a two-digit number. Okay, we know that we have a two-digit number. Therefore, in a two-digit number, we will have a tens place and we will have a ones place. We'll have the ones place. Okay. Now let's first take for this one, that is this, the smaller digit is x and the larger digit is x plus 3. If we put the smaller digit at the tens place, that is x, right, and the larger digit at the ones place, that is x plus 3, that is the first case. That at the tens place we put the smaller one, that is x, at the ones place we put x plus 3. Now tell me, what will be the number then? We know that the multiplication factor of a tens place is what? 10. So, and the multiplication factor of the ones place is 1. So this becomes x times 10 plus x plus 3 times 1. This gives you 10x plus x plus 3. This gives you 11x plus 3. Okay, this will be your number. When you take x at the tens place and x plus 3 at the ones place. Now those of you who are getting confused that what is this actually, you know that if a number is 25, you can expand it as 2 times 10 plus 5 times 1. 10, the multiplication factor of the tens place, 1 the multiplication factor of the ones place. This much we know. So if the digit is x and x plus 3, your number will be this one, 11x plus 3. Okay, but some of you will say that, hey, why can't we put x at the ones place and x plus 3 at the tens place? And that's the point. Let's put it. So in the second case, we put this x plus 3, that is a larger digit, at the tens place, and this x at the ones place. In that case, your number will be x plus 3 times 10 plus x. If you solve it, you get 10x plus 30 plus x. If you further solve it, you get 11x plus 30. Okay. So for this one case, we have two subcases, subcase 1, subcase 2. In this subcase, you are putting the larger digit at the smaller digit at the tens place and the larger digit at the ones place. But in this case, you're putting the larger digit at the tens place and the smaller digit at the ones place. So the next question that should come in your mind is that if we have these two subcases, will not we get two different results? Yes, you will get two different results, because here we have only this much information that the difference between the two digits is 3, right? We don't have any further information. So in that case, you can have different results. Like suppose, let's say that your number is 25. So 5 minus 2 is what? 3, right? It's satisfying it. But your number can be 52 as well. It's also satisfying. 5 minus 2 is 3. Your number can be 36. 6 minus 3 is 3. Your number can be 63. 6 minus 3 is 3. So if 25 is correct, then 52 is also correct. If 36 is correct, 63 is also correct. So on and so forth. But we don't know exactly what those two numbers will be. That's why we have to find that. Okay. So this much is clear. There are two subcases for this case. The same thing will be for this one also. The same two subcases will be for this case, that when you take x minus 3 as a smaller digit and x as the larger digit, and when you solve for these two subcases, you are going to get exactly the same answer as you will get for this one. Okay, exactly same. So you can test for this one. We are going to solve only for this case, having its two subcases. Whatever result you will get the same for this one if you follow x minus 3 and x. Okay, so I'll leave this for you. So if you take this first case, let's take this first case. In the first case, your number is 11x plus 3. So your original number is 11x plus 3. Okay. If the digits are interchanged and the resulting number is added to the original number, we get 143. So if you interchange the digits, it means that you take x to this at the ones place and this x plus 3 at the tens place. So if you interchange the digits, tell me, will not that be exactly this one? Because here now your x plus 3 becomes the tens place and your x becomes the ones place. Therefore, your number will be what? 11x plus 30. So this is your resulting number. Your resulting number after we interchange the digits will be 11x plus 30, right? Now if you add these two as given here, you get 143. Then add these, original number plus resulting number. You get 11x plus 3 plus 11x plus 30 is equal to 143. 11x plus 11x means 22x plus 3 plus 30 means 33 is equal to 143. If you further solve it, you get 22x. Transposing 30 to the right hand side, you get 143 minus 33. So you get 22x as 110. If you divide both the sides by 22, you get x as 5. So for this first case, if your when x comes as 5, your at a tens place is what? 5, and at a ones place is what? 5 plus 3, that is 8. So for this first case, your number will be 58, right? Okay. If you follow this first sub case, your number is coming as 58. What if we take this sub case, that is, if our original number was 11x plus 30. If your original number was 11x plus 30, it means that at the tens place we had x plus 3, and at the ones place we had x. Okay, so in this case your original number becomes if you started from this case 11x plus 30, right? Now tell me, if you interchange the digits, that is x plus 3 goes here and x plus 3 comes here, don't you think that it's exactly this one? When you interchange the digits, x comes at the tens place and x plus 3 comes at the ones place, therefore your resulting number is 11x plus 3. So your resulting number will be 11x plus 3. Now when you add these two, the sum is actually equal to 143. When you solve for this x, don't you think that it's going to come exactly as this one, that is x equal to 5 only? Because we have the same expressions. 11x plus 30 was here, 11x plus 30 was here, 11x plus 3 is here, 11x plus 3 was here. If you add these two, you're getting 143. If you solve, you get x is equal to 5 only. Then the thing that will come into your mind is, then what's the difference then? The difference is here. Now in this case, when x is equal to 5, at the tens place will be 8 and at the ones place will be 5. Therefore your number will be 85. In this case it was 58, in this case it is 85. 8 minus 5 is 3, 8 minus 5 is 3, but we are following two different sub cases, right? This is sub case 1, this is sub case 2. And so are both these two results correct? Yes, both these two results are correct. Sum of the digits of a 2-digit number is 9. When we interchange the digits, it is found that the resulting new number is greater than the original number by 27. What is the 2-digit number? So the information is that we have a 2-digit number. We have a 2-digit number, right? And the sum of 2 digits is 9. So if we assume that one digit is x, then what will be the another digit? That will be 9 minus x, right? One will be x and another one will be 9 minus x. If you want to check it, then as given here, the sum of the digits is what? 9. So x plus 9 minus x, you get 9, right? Okay. Now, if it's a 2-digit number, then clearly there will be a tens place and there will be the ones place. Tens place and ones place. So if at the tens place comes x, then at the ones place we take as 9 minus x. If this is the condition, then what will be the number? Number will be, as we have discussed here, same thing here, x times 10 plus 9 minus x. So your number will be 10x plus 9 minus x, that is 9x plus 9, right? This will be your number when at the tens place you have x and at the ones place you have 9 minus x. So same question will come into your mind as it would have come like in this question, that can't we put 9 minus x at the tens place and x at the ones place? Yes, you can. Okay, so if you put this one, in this case your number will be 9 minus x times 10 plus x. You solve it, you get 90 minus 10x plus x, and your number will be 90 minus 9x. Okay. Okay, so we have these two cases here. Now let's take for this first one. When we interchange the digits, it is found that the resulting new number is greater than the original number by 27. When you interchange the digits, so if you bring this x at the ones place and 9 minus x at the tens place, tell me, isn't it the same thing like this one? Yes. So if your original number was 9x plus 9, we are solving for this first case. If your original number is 9x plus 9, what will be your resulting number? Your resulting number will be 90 minus 9x. Very good. The resulting new number is greater than the original number by 27. This is greater than this original number by 27. So it means that 90 minus 9x is equal to 9x plus 9, that is original number, plus 27, because it's greater than this one by 27. If you solve it, you get 90 minus 9x is equal to 9x plus 36. Solving this one, you get 90 minus 36 is equal to 18x. If you solve this one, you get 18x is equal to, this comes as 36, 40 and 54. So you solve it, you get x as 3. So if your x is 3, then at the tens place will come 3. At the ones place will come 9 minus 3, that is 6. So your number is 36. Right? 36. Let's take for the second case. In the second case, your original number is 90 minus 9x. Okay, this is the original number. And when we interchange the digits, that is when 9 minus x goes at the ones place and x comes at the tens place, tell me, isn't it the same thing as this one? Yes. Then what's the resulting number? Resulting number is 9x plus 9. 9x plus 9. This is the resulting number. So 9x plus 9, 9x plus 9, the resulting number is greater than this original number by 27. 90 minus 9x plus 27. You get 9x plus 9 is equal to 90 plus 27 minus 9x. You get 9x plus 9 is equal to 117 minus 9x. If you transpose minus 9x to the left hand side, you get 9x plus 9x. At the same time, if you transpose this plus 9 to the left hand side, you get 107 minus 9. This gives you 18x is equal to 108. And then if you solve it, you get as x as how much? X as 6. Okay, so in the second case your x comes as 6. What will be at the tens place? 9 minus 6, that is 3. What will be at the ones place? That is 6. Ooh, we got the same result, right? So whether you follow this first one or you follow this second one, in both the cases you are going to get the same result, right? A positive number is 5 times another number. If 21 is added to both the numbers, then one of the new numbers becomes twice the other new number. What are the numbers? Okay, very interesting. We have a positive number. We have a positive number. So no scope for negative number. Okay. Is 5 times another number. Okay. If 5 times another number, then if one number is x, then clearly another one will be 5x. Clearly this is the smaller number and this is the larger number. Okay, if 21 is added to both the numbers, 21 is added to this one, 21 is added to this one, then one of the new numbers becomes twice the other new number. Tell me, if you add 21 to this smaller number, this becomes x plus 21. If you add 21 to this number, this becomes 5x plus 21. Now, which one will be the twice of the another one in these two? Because it's talking for the new numbers. This is the new number, this is the new number. These two are new numbers. Which one will be the twice? Clearly, this will remain the larger number or the greater number, and this will remain the smaller number. Therefore, this 5x plus 21 is going to be the twice of this one. Is going to be twice of this one, because if this is larger, then and if this is smaller, then it doesn't matter if you are adding, subtracting, or multiplying, even dividing the same with the same value, then this is going to be the larger in all those 4 cases. If you are doing with the same number, not with a different number. So since we have added the same 21 to both these numbers, then in that case, again this is going to be the larger one. Therefore this will be this twice of this one, as it's given here. One of the new numbers becomes twice the other new number. So it is very important to know that which one will be the twice of which one. This larger number will be the twice of this smaller number. Okay, what are the numbers? Now solve it for x. This is 2x plus 42 is equal to 5x plus 21. Transposing 2x to the right hand side, this becomes 42. Transposing 21 to the left hand side, minus 21. 5x minus 2x. This means you are getting 21 is equal to 3x. It means you are getting, if you divide both the sides by 3, you get x as 7. You get x as 7. So one number is, small number is 7, your smaller number is 7, and your larger number will be 5 times 7, that is 35.